Hi all. Today I'm going to give you an introduction to Survey. Survey is an HPC performance tool from all of us at Trenzis Energy. Many performance tools give you detailed information about a narrow set of metrics, such as detailed information about I/O characteristics or memory use. But Survey was created to give the user a wide range of information about the HPC application, containing only the most critical metrics. Once those metrics help you identify the source of a potential problem, you can then switch to a different tool to get more detailed information if you need it. Survey also collects metadata about the run, including information about the hardware, operating system, linked libraries, run environment, and all kinds of other data. This metadata will allow you to put the survey metrics in context in order to help you identify the cause of any problems or variations in data. You can even use Survey to collect metadata about your runs without using the runtime collector. To demonstrate Survey, we're going to use the Lulish application. Lulish is a proxy application that contains both MPI and OpenMP code, so it's a good one to use for demonstrating an HPC performance tool. After Survey is installed, all you need to do to use it is to input Survey on your command line, followed by a call to the application that you want to measure. In our example, we ran Lulish with 8 ranks by using survey MPI run-n8 Lulish 2.0, that's the name of the executable. When the run is completed, the survey output looks like this. There's a survey section at the top giving you basic metadata about the run, including the executable name, the host machine, the start time, the overall job time, the CPU resources, the command used for the run, the number of ranks, threads, and processes used by the run, and the estimated memory available on the host machine just before the run started. In the next section, there's a summary of the measurements of the run. It starts with a breakdown of the percentage of total runtime spent on MPI operations, I/O operations, and compute operations, which is basically everything that's left after you subtract I/O and MPI. Next, there's a breakdown of the OpenMP time. How much time was spent in OpenMP operations and the percentage of that time to the overall runtime. And then we have a breakdown of the memory usage of the run, the estimated amount of memory available to each thread, the average maximum usage per thread, and the percentage of that usage against the overall memory available, and the same metrics for the average memory usage per thread. The next section of the report contains the affinity information, that is, which CPU cores were assigned to which ranks, and how many ranks did that rank use, and which NUMA domains were those cores assigned to. In our example, we have 8 ranks with 1 thread each, and a unique core is assigned to each rank. There's only 1 NUMA domain. We have another video that goes into more detail about affinity and how it can affect your performance results. Check the description of this video for a link. Finally, we have some rough suggestions based upon the measurement results. These recommendations are a fairly new feature and we're still working on them. But in this example, they are telling us that our MPI and memory usage are fine, and that if we wanted to, we could probably add more ranks to future runs. Likewise, our I/O usage is low. If this app was using visualization, you could increase the resolution. And since there was only 1 NUMA domain, there are no NUMA imbalances found. The final 2 lines of the survey output shows you where you can find the survey report files. Survey will output several different files. First, there's a report JSON file. This contains all the measurements from the runtime collector. There's a lot of detailed information here with measurements that aren't included in the summary that is output after the run. Look for more details on this in a future video. There's also a CSV report file. This contains most of the information in the report JSON file, but in CSV format for those of you who prefer this format. Next, there's a metadata report file. This contains all the data that we collect before the run. There's information on the CPU, the executable, linked libraries, the file system, the operating system, and all kinds of other data. Look at the description of this video for another video describing this metadata. Finally, there's a tar file generated. This contains all the raw data collected by the runtime collector, plus another copy of the metadata file. If you want to recreate the report files using Survey Viewer without rerunning the application, you will need these files. And there is a video describing how to use Survey Viewer. Check out the description for the link. And that's it for this intro to Survey version 1.10. If you like this video, please give it a like and subscribe to our channel. And leave your comments below if you have any suggestions for future videos. Thanks a lot. Bye.